Welcome to the first practicals of Introduction to Structured Programming. As you can see, there are now 3 new people sitting here, so maybe we start by introducing ourselves. Maybe ladies first.
Yes, so I'm Julia. Hi, and I'm studying computer science in my master's now.
Hi, I'm Tanya. I'm studying software engineering and management in my bachelor's.
And I'm Michael, and I'm studying computer science and mathematics in the master. Okay, then I hope that everything works fine and that you can hear us well enough. So we will start immediately with the first practicals. And let's see what is our plan for today. We will start off with some organizational matters. And then we will in particular have a look on the weekly exercises that were presented last lecture for the first time. And we even solved one exercise, so you have a benefit when you watch the stream today. And then we will talk about how you can code on your device. So we introduce the virtual machine first. We will see what this is. Then we talk a bit about Linux and show a few commands. Then we also talk about Git and GitLab. So if you don't know what this is yet, no problem. Tanya will present this then. And then we also have a look on the simple C program that you can imagine and try to implement this on our device here. Okay, so let's start with the not so interesting stuff, but very important stuff, the organizational matters. Just to sum this up, what we do here in the practicals. So you can see this as an additional unit to the lecture, and our goal is not that we present new stuff and new concepts, but rather that we repeat the stuff and concepts that was done in the previous lecture. And we do not only repeat it, but we would like to present it in a practical way. So we do a lot of live coding examples here, and that may help you when you do the assignments later on. Yeah, then of course we also talk about homeworks and assignments briefly in the practicals. In particular, we announce when a new thing, a new task is there that you need to do. And you also always have the opportunity to ask questions. Yeah, I think I have it on the next slide.
Oh, sorry.
So in the YouTube chat, feel free to ask questions whenever you like. We cannot guarantee that we answer all of them, but we will always have a look on the chat. And yeah, if you write something stupid, please don't write something stupid here, but then otherwise we will delete it. Yeah. And in 2 weeks' time, we will then move on to the lecture hall, and then you can, of course, always ask a question during the session or also after the session in the lecture hall. Then one important thing, it was also mentioned last time in the lecture, but it's really important, so we will say it one more time here. A few hints about our course here. ISP is really a foundation for all further lectures. So probably everyone tells you that in the first lecture, in the first semester. Analysis is important. ISP is important, some other courses are important, but ISP is really important. Yeah, you really need this every semester. The concepts that you learn here, you need them every semester. All the programming courses will build on what you have learned in ISP. So take the course really seriously. And it's not that you only need to know a few concepts of this course. Everything that you learn here are foundations that you need to know. So it's not enough to take half of the course serious and the second half you don't care about it. Then you will have a trouble in the next semester.
Yeah, and that's also why the practicals are so important, because you repeat everything that you learn in the lectures.
So basically you hear everything twice, and then you are forced to do the weekly exercises, so you need to apply it practically. Then you need to do the assignments, apply it one more time, so hopefully then you remember a lot of our course. And that is also important. Do not say, okay, it's beginning of the semester, that's easy, I can do everything, and then start with the tasks only a few hours or days before the deadline. really try to take it serious and start early that you manage to do everything. And I think last time also there was this calculation how many hours you need to invest for our course, and this is 12 hours a week. This is already a lot. And what happens if you don't do anything for a course for like 1 or 2 weeks? Then you need to spend 24, 36 or even more hours to compensate that. So please really learn along and invest the time now and not when it's then too late. Yeah, and this is last message here: practice, practice, practice.
Maybe what we can also mention here is that even if you can't invest 12.5 hours yet into like doing assignments or something this week, for example, again, you can practice or already get familiar with concepts. Really try to get those hours in.
Yeah, one more hint, which is not related to the to saying it's so important, our course. We have the course websites which we'll also show today, and with which we also work today. And it's really important that you read through our guides, that you're familiar with the course and know what you have to do and what is important for the course. And then there's already the first very important thing. Today, the registration for coding session 1 starts. So we will open this after today's lecture, so in 3 hours probably. And then you can select your time slot for the first coding session in the TeachCenter. Maybe can you show us where the TeachCenter is, or what the TeachCenter is?
Yes, so here you are at the TeachCenter, and you can find the coding sessions below the weekly exercise and assignments at the very bottom here.
And then this first bullet point will be marked as green, and then you can register.
Yeah.
After.
So right now, when it's orange and you click on it, nothing happens.
Mm-hmm.
So don't worry, that's just because they're not open yet. When they're open, we'll have this green emoji there.
Mm-hmm. Okay, and the homework 1 is then closely related to the coding session 1, because you need to do the homework 1 before the coding session 1. And yeah, it will be available within the next days. Also then we will announce this. The corresponding bullet point in the TeachCenter will be green, and the submission is then before your coding session 1 time slot. So if you register for Tuesday in 3 weeks, then you need to do the homework until Tuesday in 3 weeks before you go to the coding session. And the topics of homework 1 are Linux and Git, and as far as I remember, that is what we talk about today. So this is a good introductory unit now for the first homework.
There were some questions.
Yeah.
You want to do here now? Okay, so is the coding session different to the assignment interview? Yes. There's this something different. The coding session is more for practice. In the assignment interview, we review if you did the assignment on your own. Yeah. And maybe something regarding how you can practice besides weekly exercises and the assignments. Well, at the end of our practical sessions, we often say something that you could do at home now, that you can try out and practice. And generally, at the end of the practicals, you will have many things I'm sure you could try out.
Mm-hmm. So, for instance, the things that you can do today after today's practicals to set up your device with everything that we explained today.
Yeah.
Okay, one more organizational thing we have, which is the weekly exercises. I think that's the one that you're most familiar with already. So all the weekly exercises that are released currently are related to assignment 1. So the deadline for the last week, this week, and the next week is always the 29th of October. And yeah, week 1 is available since a week, and week 2 will be released today. So I think you're familiar what the weekly exercises are, but maybe you're not entirely familiar what you need to do in the weekly exercises. So maybe we can also show this today.
Yes. Before I start, I just want to quickly check if I can do something here. Yeah, so there was some key, the background was black.
Ah, okay.
Okay, but it looks good now. So how can you solve a weekly exercise? Well, the first thing you always want to do is you go into the TeachCenter, and yeah, we have everything you want to do. So particularly now we can see that at the weekly exercises we have already this green point here, so you can do this already. Yeah, so note that the deadline is only on the 29th, so you don't need to worry if you didn't manage to do these exercises yet, and you can always repeat them and try again. So if you click on this, then we can see, okay, here we have the week 1, and we can also see that we already tried this once, but you can always repeat this, and then the best try will count. So don't worry if you already submitted something, you can check again later what you submitted, and then you can repeat the weekly exercises, so there's no pressure that if you submit you can undo anything or something. Okay, so let's start. We'll do the first weekly exercise now, and we can see here we have a description. So week 1, operators and variable, and our first task is that we should create a program which displays hello world. So one of the most simplest things, the first thing you did last week in the lecture. And yeah, we have an example here, so it should output hello world. Then down here you have the part where you can now code your weekly exercise. So we now need to implement this hello world program here. Does anyone in the chat have an idea what we need to do here so that we can output hello world?
Hopefully everyone has an idea now, because the exercise is available since a week.
Yeah, I already see it. Printf hello world. That's exactly what we need. Printf is the function which we need so we can put something to the terminal. And maybe if these terms now don't mean anything to you, don't worry. You will learn them very soon. And then in here we can type in hello world. I'll now leave out here the exclamation mark just so we see what happens if we don't complete it correctly. If we click on prüfen down here, you can see that, okay, we need to pass all tests so that this weekly exercise counts. So there can be multiple tests here, so, and in this table here, this is just the first one, but as we can see, it expected hello world with this exclamation mark here, but we just got it without it. So we need to try again. I put this here, click again, and now when it's green, we passed all tests, and only when we passed all tests, we'll get the points for this week.
Yeah, so this answers also the question from the chat, because someone asked here if when is a exercise fulfilled, how it is created, and yeah, you need to pass all the test cases of an exercise, and then it counts to be correctly solved. Yeah, but it's not about code quality in these exercises in the TeachCenter.
Because it also just came up in the chat, the time spent on the exercise also isn't important. So it's really just about passing the test case.
They can also do the exercises multiple times in the time frame,
yeah,
until you pass all the test cases for all exercises.
Yeah. So, and don't worry yet if you didn't manage the exercises for week 1, you still have time.
And since it came up also, manually, the code in here isn't manually created. That's really just with this code runner in the TeachCenter.
Okay.
Yeah.
Actually, does hard coding the answers count? That's a good question.
Probably not possible for later exercises. For the first one, it's here that there is like one solution and you write the output, but for further exercises, you need to do calculations and implement it in a more general way.
Yeah. And if you hard code just for the test cases, then this won't count.
If you don't know what hard coding is, no problem, don't bother with that.
Probably
Yes.
better if you don't know.
And as I said, you need to pass all tests so that an exercise counts toward those exercises you need to complete to complete above 50% of the exercise, so that you get full points for the assignment. Okay, then the next thing is, how can you code on your PC now? So we saw it how you can do it in the TeachCenter, how you can do it for weekly exercise, but the assignments you'll need to complete on your own computer. How does this work? Okay, and for that you need the virtual machine. Let's start with what is a virtual machine. Well, it's more or less a virtual computer that lives inside of your computer, and we provide you this machine where everything is pre-installed, so you have all the tools that you need. You don't need to install anything, and everything's already there. And it also helps you get familiar with Linux, which you will also need in later lectures, in your studies. There are two versions of the virtual machine. Let's look at our course website where everything is explained. So if we go back to the TeachCenter, then here you see the Notion, which is our course website. And you're here, and then everything that we explained today, you can also find if you scroll down here, practicals, general guide for the practicals. The assignments and coding sessions and everything you already heard last week. We also already talked about organizational matters, partly today, partly last week. So we are at set up your device. And the first step is you need to decide how you want to work, and our recommended approach is to just use our virtual machine, because then there's everything installed. Of course, you can also install all the programs you need directly on your computer, but this could come with issues, so especially for beginners, we recommend the virtual machine. So let's open this, and we can see, okay, the first thing, installation, you need VirtualBox, which is a program to run this virtual machine. Open this, you can see, okay, here's this website.
And on the website you download them for the right.
And on the website you download it for Windows, macOS Intel, or Linux. For macOS Apple Silicon it's a bit different. I will explain this later.
Okay, yeah.
Yeah, so first, if you do not have macOS with a new Apple Silicon chip, so with M1, M2, M3, M4, this description now is for you. So for most of you, you can listen now. The next thing you want to do is, you can here download our virtual machine. We already did that here. You can see if we open this directory, we already have this file that I downloaded from the website here. Then, this is a program you just downloaded and installed. And what you need to do is, you won't have any virtual machines already here. You just set already everything up. And what you do is you just drag this file in here to the right part. And then click here on finish. I won't do this now because this takes some time and we already set that up. So I'll cancel now. You could, of course, also click here on import and then select the correct file. So both works. And then when you imported it, you will see ISP WS25.
Actually, it's named as
this one?
Yeah, it's named like this, but it's the correct thing because we didn't change it from last year.
Yeah, then you can just double click it, and the virtual machine will open a new window, and you can see, okay, in here you are in this new operating system on this virtual machine, and the password, maybe this is important, is the same as the username, so it's student. and then you can log in and everything should work. So now you are here on the desktop of the virtual machine. So, and for those of you who are not on x86, do not have some standard Windows, Linux or macOS Intel machine, but are on macOS ARM or Apple Silicon or any MacBook which has one of these processors, then you need to do this a bit differently because there's a separate virtual machine for that. Yeah, sorry, we are here. You can see here is a separate section for installation on macOS. What you want to do is you need to program UTM, which is different from this virtual box, and then you can click here on download, which will download this program. Also note that if you click here on the Mac App Store, you will see that this costs something in the App Store, but you don't need to buy it. It's free if you click here on download. So yeah, just if you get confused if you click on the wrong button. Then same as before, you download the macOS VM here, drag it into UTM, then double click it and it should start. So it should be very similar. Maybe just something, two things you need to be careful about when you use this second macOS virtual machine is you could get some error that you don't have enough free disk space. We have a section here in the Notion what you can do to increase this. And the second thing is when you get then your assignment, you need to go back to this page and look what you have to do, because you need to replace the test run in your repository. I know this sounds like a lot now, but just when you have your assignment, remember, okay, I use macOS, so I need to go back here and then read this again, and then hopefully this will make more sense. Were there any questions for the virtual machine?
Yeah, there were a few questions, in particular whether it's optional to use the virtual machine or are you required to use the virtual machine. I briefly answered it in the chat, but also say it here one more time. The advantage of the virtual machine is that everything is set up. So you don't need to think about what programs you need to code, so you can directly start coding. Another advantage is that the virtual machine behaves exactly the same as our testing system does. So you can be sure whenever you run a program on the virtual machine, it will work exactly the same on our testing system and nothing bad can happen here. But of course, you're not required to actually use the virtual machine. You can also use, I talked about this in the chat briefly, a dual boot setup or Windows subsystem for Linux. We'll also see Docker in a few seconds. Also, these alternatives work, and if you know what you do, then probably another tool is even more convenient for you to use. But the large advantage of the virtual machine is you don't need to set anything up, you just download it and can immediately start.
Yeah, you have everything in the VM to do exactly what we do here in the practice. Can I use the old one from ISP 2024? And yes, it's the same as the one in ISP 2024. But 2024 we got the new virtual machine, so if you have the one from, I don't know, 2023, 2022, you need to download the new one. But as you might have seen here, yeah, it's just the 2024 one.
And just for the people who haven't seen it, Tamim also said it in the chat, if you work on something besides the virtual machine, we will test your implementation on the virtual machine, so just make sure that it behaves the same way.
Yeah. So there can be differences between your own setup and the one in the virtual machine. Yeah, I did that. Now we have also Docker as an alternative. Docker is something more lightweight, so it's not as resource intensive as running the whole virtual machine. And you especially should consider using Docker if the virtual machine is really slow to work with or it just does not work. So if you type in the machine and you feel that if you press a key, you have a delay and it takes really long, then consider to use Docker because it's faster, but it's always a bit more complicated. Just so that you see it, here instead of option A, you can also choose option B. If you have performance issues, you can use Docker, and it's also described here. You just install Docker, download our container, then put this directory in somewhere you want to work with. You also need to install Visual Studio Code directly on your computer, and then with this key combination and then running this command, you can open it in a Docker container. So yeah, that was a bit fast now. Just look, if the virtual machine does not work, just look here on the side for Docker. Everything should be explained there, and if you still have issues, you can always ask on Discord, and me or someone else will help you.
One question was asked multiple times in the chat, so that's why I ask you. Probably you are the expert. If you have an iPad and you want to do the course,
yeah,
what do you think about this? Is this a good idea? Can you work with our tools, or do you rather consider this as difficult?
I think working on the iPad will be very difficult. There might be some way to run UTM on the iPad. I think there is some to sideload UTM and then run virtual machines on the iPad, but it probably won't perform well, and it will also be it would be very difficult. Also for future lectures, I think an iPad is not that optimal to program on.
Okay, yeah.
I mean, but it could work, but yeah, I can't say more.
You really need to find out yourself then what
Yeah.
you need to do that you can start programming. Okay, I think the other questions were mostly answered by one of our colleagues, Tamim and me. I think that probably all the questions are more technical. Then maybe we continue with the next topic, and the other questions will be certainly answered by Tamim in the chat. So Linux commands. So let's have a look on the virtual machine, and from this perspective, it doesn't look very different from, for instance, Windows. But the operating system behind the virtual machine is Linux. Why is this the case? Why do we use Linux instead of Windows or Mac OS? Probably because it's more convenient to program in Linux. But also in Windows and Mac OS, you can, of course, program as well. But at the university here in Graz, usually most of the courses, for most of the programming courses, you will use Linux, and during your studies you will even implement an operating system which is Linux based. So yeah, probably that's why we work with that all the time. And most things work very similar to other operating systems, but nevertheless there are of course differences as well. And today we will not only use the graphical user interface, which you're probably used to in Windows, but we will also have a first look at the command line. Okay, what is the command line or the terminal? So when you open the virtual machine, you find this here. So terminal emulator. So we double click it, okay, and then we are here in the command line. So maybe make it a bit larger. Okay. Okay, what is this command line now? What do we see here? Okay, here there is some name, the student at ISP. Okay, this is basically the user and the name of the computer, in this case the name of the virtual machine. And then here in this blue, which you hopefully can see well enough, it states desktop. And this indicates in which folder you currently are. So basically opening this terminal here is equivalent as if I have a folder open and I go to desktop. So these two things are more or less now the same. And if I move, for example, into this folder, I can also press right click and then open a terminal here. And then I will get the command line interface, which states, okay, we are now at desktop and then hi ISP. So we are in this folder. So this is the relation between the command line and the graphical user interface in this case. What can we do now with the command line? I will show you now a very simple command, which you probably not use very often, but this is one of the simplest commands, where we just type pwd for the path to the working directory. So this just is the path to the directory where we're in. Yeah. So I just entered the letters and then typed enter to execute this command, and now I get a result. So this is the result of the command. And it states, okay, we're at home, student, desktop. So I'm open now this folder structure again at desktop. So this is the relation between this command line interface and this folder. And the path is exactly what is written here. Yeah? So we're home, student, desktop. And now if I go to the other command line interface that I opened previously, which is also in the hi ISP, if I type here the same command, I of course get home, student, desktop, hi ISP. Okay, now maybe close this again and let's stay on the desktop for now. Now, if I'm just in the command line and I don't see the GUI, that's a graphical user interface, I don't know what is contained in this folder called desktop. So maybe a first thing would be now to see what is contained in this folder. And we can do this by typing ls for listing what is contained in this folder. So if I type ls, I see here, okay, we have this code.desktop. So this is this program here. Then we have the Firefox program. This is this one here. The folder hi ISP, which is here, and the terminal application. I can also type ls-a, or let's say ls-al, then I get a more detailed overview, so it's aligned, and I also get overview when it was created, which permissions there are, and so on and so forth. Important thing is with ls I can show what is contained in the folder. Okay.
Yes.
Yeah?
Some questions just if you have now more involved problems with the virtual machine, please rather ask them on Discord than in the chat, because then there we don't overlook your message, and also you can post screenshots so we are able to better help you. Yeah.
Okay. Okay, what could the next thing be that we want to do? Maybe we would like to go to a different directory. So if we are in the GUI, we double click on hi ISP. How can we do the same thing in the terminal? So we type the command cd for change directory, and then we type the name of the directory that we want to change to. So in this case, hi ISP. Press enter, and as we see now, we're at desktop hi ISP, so we're really in this folder now. And now if I type again ls, then nothing is shown here because the folder is empty. So this makes a lot of sense. Now, how can we go back from hi ISP back to the desktop? So I will probably go here maybe in the graphical user interface. In the command line, I need to type again change directory because we would like to move to another directory. And then I type 2 dots here, and 2 dots always indicate I go back one step. So I go from hi ISP back to desktop. And as you can see, we are back at the desktop now. Okay, now imagine that we don't see the GUI here, so this is not here. We would like to go to the folder hi ISP, but we're not entirely sure how this folder is correctly named. Yeah, so we know there is some folder that we want to change to, but we don't know what this folder actually is. So one option would be now to type ls, see, okay, here is this folder hi ISP, and then type cd hi ISP. But this would be boring. Yeah, okay, so let's do something else. I can also type cd with space and then press the tab button. And in this case, if I press the tab button, it immediately selects hi ISP because there is just a single folder which is called hi ISP. So it knows there's only one option where we can change to. So this is this to this directory hi ISP. Okay, make this now more interesting. Let's create a second folder. So in the GUI, I would press create folder, give it a name, maybe test1, and then we have created this folder here. How can I do the same thing in the command line? I have one more command, make directory, mk here, make directory, and then I type the name of the folder that I want to create. So for example, test from the command line interface, CLI, test CLI. Okay. Now if I create this folder, you already saw on the GUI, this test folder is already created. And if I type now ls, then we can also see in the command line that there is now the folder test CLI and the folder test1. Okay, so this works, everything fine. And now if I type cd, and now maybe I want to move to some folder, but I don't know yet how this folder is exactly named, and press the tab button again. Then there are suggestions written from the command line which folders exist. So I just pressed, just wrote cd space and then the tab button, and then there are some suggestions. And now if I type hi and press tab again, then this will be auto-completed because it's clear how this folder will be named. And if I instead would like to move to a test folder, if I just write test or te now, press tab, then it won't be auto-completed because it's not clear yet if I want to move to test1 or test CLI. Now if I write, for example, in C and press tab again, then it will be auto-completed. So tab is your friend in the command line, I would say. Okay, so now we are in the folder desktop test CLI. So we'll also do this in the GUI. And everything clear so far in the chat or other questions? I think it's okay. Then we move on. Now, instead of creating a folder, we might also want to create a file. So let's create a text file. And to create a text file, you write touch and then the name of the file. So my file, for example, and give it the right ending, file ending.txt. And if I do this now, then I have created here a text file, as you can see. And if I run ls again, then also in the content of the directory, the myfile.txt is listed. Okay, let's see whether I can do that. I will just open the file now manually in the GUI and write some content here. For example, hi ISP. So I did this now manually because we will not discuss this, how to do this in the command line for now. Now, the question would be, can I also show the content of a file in the command line? And also for that, there is a command. If I write cat and then the name of my file, so again, I just need only to write the M and then press tab, then it auto-completes to the file name because it's clear to which file I refer to. Press enter, then the content of the file is written here in the command line. So basically as if I would open the file and show the content of the file. So a bit more, yeah, we can do a bit more. Maybe we want to move the file now from this test CLI folder to the test1 folder. So okay, I could now go here and press cut and then insert it in the correct folder, but how can we do this in the command line? In the command line, we would use the command mv for move. Then we need to specify what we want to move. we want to move my file. And now where do we want to move the file? So if I go here to the correct location where I want to put it, I need to go back to the desktop and then go into the test1 folder. And to do this, we said going back is 2 dots. Then we need to write the slash because between two directory names there's always the slash. So this refers to going back. And then we can write test1, test1. And then the file will get moved from the current position to the folder test1. Let's see whether this works. So I pressed enter on the command, and if we go back to test1, now the file is contained here, and in the test CLI, the file is not contained. Okay. If we write cp instead of mv, then we copy the file to the new position. Yeah, okay, one more thing maybe which is interesting. So go back to the desktop again. So this means cd and then ... again, because we are in a folder, we want to move back to the desktop. So we're here at the desktop. Can we also execute programs? For instance, can we open the browser from the command line? And also this is possible. Then we need to know the name of the browser, for instance, Firefox. And if I run now the command Firefox, press enter, then the browser opens here. So we can also execute such programs as Firefox here. Now, this is maybe one important thing. If I could, of course, close the Firefox. Okay, you don't see this. I could, of course, close Firefox on the X here now. Okay, this is not open here. Okay, never mind. So I just close Firefox now. I cannot demonstrate this what I wanted to show. So we can execute programs here.
You could type cat out any parameter.
Okay. So if I run some program now, so cat, this was to view the content of a file, and now this program does not terminate. Yeah, so we cannot type anything more because cat doesn't know what to do now without specifying a file. How can we then interrupt a program which is running in the command line, but we would like to stop it, but we can't? Many students just close the terminal, but we are more fancy. We just press Control-C. And Control-C terminates a program which is running in the command line, which we, for instance, cannot terminate by other means.
Yeah, and this might also cause you confusion if you would try to copy text from the terminal and you press Control-C, then it just does nothing, so you don't copy anything. To actually, if you select text and you actually want to copy it, you need Control-Shift-C. So it is a bit different, and yeah, everywhere else.
Yeah, so basically for copying Control-Shift-C and for inserting Control-Shift-V then in the terminal. Yeah. One more thing which is important, maybe we can also remove folders from the command line. So for instance, let's remove the test CLI folder. So I could type remove test CLI, and rm would, if it's a file, it would remove it now. But it doesn't remove it here because it's a directory. So we need to run rm and then specify one more options, which would be minus large R, and then specify the name of the folder that we remove. And then you see the folder is removed here. And let's also do this here for the test1 folder, and also this folder got removed. But remember, in the test1 folder there was also the file contained, and you did not get asked whether you should remove this or not. So be very careful when you remove something. You will not get asked, and I think it shouldn't be in the trash can.
No.
Nothing is in the trash can here.
So the trash only contains item you delete in the user interface. So if you are on the left in the folder, then right click delete something, it's in the trash. But if you RM something, then it's just gone. So be careful with that.
So this the file that we created here with this RM got really removed, and we cannot restore it. Yeah, so maybe don't use RM at all. And then one more hint, maybe, I don't know why there are so many questions.
Yeah, you shouldn't run commands that someone else just gives you without trusting them. And if someone writes potentially harmful commands in the chat, we'll delete it. Yeah.
So just to demonstrate this, for instance, if I would now remove some folder here which is important to the operating system, for example the home folder here, or student with the home folder, then maybe you cannot run the virtual machine anymore. So really be careful with the RM. That's why I wanted to show it to you. Yeah. So I hope this was not too fast to you. I just wanted to give you a brief insight. You will use most of these commands when you work and you code through our course. Probably in the beginning you rather use the user interface, but once you get used to the commands, then this will be faster than using the GUI, and you probably just rely on commands. And there exist, of course, many more. Just give you a brief overview of the most important ones.
You learn more in the first coding.
Yeah, and also in the homework you need to do something with Linux commands. And if we go back to the slides, I will not go through the slide, but I also have an explanation of the commands that I showed today on the slides. Maybe just one thing, we talked about this very briefly. We talked about this dot. This indicates the parent directory, so we want to move back one directory. There are also two more symbols related to that. If we have just a single dot, then this indicates the current directory, and the tilde indicates the home directory. Just to briefly show this here, if I would type cd and a dot, so let's see whether this also works.
I think the stream is down. Okay, reconnected. Is it back? I think it should be back.
Looks good, I think.
Yeah.
Is it back? Okay. Yeah.
Okay. And now, if we want to go back to the desktop from the home directory, we can of course switch with cd back to the desktop. Yeah. Okay.
Yeah. There was some question how you can find all these options for commands. There are basically two ways. You could either, for most commands, you can just type --help, which displays some.
But let me see that. So cd, for instance, --help. Okay. Yeah. We make it a bit larger.
Yeah. Okay,
then there is everything explained here.
Yeah, or you could type man and then the command, which also gives you that.
Man.
Similar thing.
cd. Okay, this is
I
not.
There's nothing for cd.
Okay, but you can use the --help, and you see the options here. So for instance, for mv, for moving a file, there are many options which we did not discuss yet, which you may need at some point, but which are not that important at the beginning. Or you can simply Google the commands. This is also an
for
option.
cat, for example, there exists a man page, because cd is...
So man, cat.
Yeah.
Okay, this would be possible.
And then you need to read a bit to find out how you quit this again.
And here. So we just need to press Q. Okay. Are there any more questions related to commands?
I think we answered most of them.
Okay, then we move on to the last large topic of today.
Which will be the platform that you will be uploading your code to when we actually get to the assignments in the practical. So let's talk about Git and GitLab. This will be the platform we're using in the practicals, and which is also really commonly used in general in the coding world. There's also GitHub, but we don't have that at TU Graz. We use GitLab. So let's start off. What is Git? So Git is essentially a version control system. You can think of it like a cloud, like Microsoft OneDrive or Google Drive or something, just with a lot of extra stuff, basically. So you also have online folders that you work on, and you have local copies of those folders and files, and you upload your changes to the platform. So you have them anywhere. Just that instead of folders, we have repositories, and which is basically, think of it for the start just as an online folder, and yeah, you copy that to your computer, you make changes, and you upload it, basically. Exactly. So let's talk about the advantages of Git, because it is a lot more convenient than a regular cloud. As we said, it's a version control system. That means there's a version history. What that means is that any changes you make to a file will make sort of a new version of that file, and you can always easily fall back to earlier versions of files. So if you upload something that breaks some existing code, it's not hard to actually fall back to the last version of that and see what kind of changes actually broke what you had. And from a collaborative perspective, it's also nice because if you think back to school times or something, you probably worked with people on the same Google Doc, and then you worked on the same spot, and you overwrote what your colleague just typed, or you sent files to each other via email or something, or Discord, WhatsApp, something like that. So we don't need that with Git. With Git, you can explicitly invite people to projects and say, okay, only these 3 people are allowed to make code changes. And Git also has built-in functionalities to make sure if 2 people work on the same thing, that you don't actually overwrite what your colleague has done in the meantime if you upload the changes again. But that won't be that relevant in this course because we're doing individual work here, but just for reference.
Yeah, I think this question comes quite often. So all the work you do here is individual and not in groups.
Exactly. So we need some way to basically communicate with Git so that our computer actually can talk to the platform, and we can just download the folder and work on it locally and upload our changes. There's not only one way to do this, but let's say the easiest way to do this would be through an SSH key. Now, you don't need to be concerned with what SSH is at all. That's just a protocol. All you need to know is that we need this key in order to just communicate with the platform. Otherwise, you would need username and password, and entering that every single time can get quite annoying. So it's easier to just set up the communication with the SSH key.
And also it doesn't work with multi-factor.
Oh, right. Yeah, that too, with the 2-factor authentication. And the good thing about the SSH key is also you set it up once, and on that device, it's going to work every single time.
Hopefully.
Hopefully. But if nothing gravely wrong happens, it should work. So this key must be generated on your computer, and it must then be uploaded to GitLab. And these are the old slides, aren't they? There's a public and a private version of the key, and the public version must be uploaded to GitLab, and the private version of the key, best thing is you never look at that, and you don't even share it with anyone, because technically if you leak your private key with someone, then they could pretend to be you, for example. So let's just don't touch the private key. We really don't need it. Everything that's relevant to us now is the command right here. This is just the command that we need to enter in the terminal to effectively generate our key. So we'll just switch back to the VM, log in once more. And you can execute this command anywhere. It doesn't really matter. We've already seen Control-Shift-V, but if you do right-click, you can also just paste it here. If I copy it correctly, of course.
I hope the copying works from the slide.
Copy.
Yeah.
Okay, it does. Okay. Never mind. Right, so that's our command. Then we'll just press enter. Now it's generating the key. Then it's just asking us which file we want to save the key in and the standard path that it's going to use. Just don't worry about that. We don't need to specify anything here. You can just hit enter. Then it's going to ask us if we want a passphrase for the key, so like a password to further protect the key. Since we said we want to do this to avoid entering anything when we upload stuff to Git, we will just leave this empty by just pressing enter. Then it's asking us to confirm that again. So we press enter yet again. And then it's telling us, all right, the identification has been saved, public key has been saved. And don't worry, this isn't the key. This is just, yeah, we can just see that it worked this way. So the next thing that we need to do is that we need to get to the key.
Can you do this in the command line now with what
Yes.
we've learned before?
Yes, we can do that. So in order to do that, we need to go back to our home directory and not be in the desktop. In order to do that, we need to just enter CD for change directory without anything else. So no tab, no nothing. And we press enter. And then we go right back to the home directory itself. So if we do pwd again, you can see we're in home student. So the home directory of the student. So the student profile of the machine, so to say. All right, and if we do ls here, we can see all the folders that we have here. Now we saw up here when we generated the key that the key landed in this .ssh folder. And you will notice that we don't really see that here. That is because if you have a dot in front of the folder name, that means it's a hidden folder. So it's not going to be displayed by the regular ls command. But we can still change directory into it. So we can still just enter the folder because it does exist. It's just not being displayed. So if we do cd and .ss, I'm just going to tab here again, and it's going to auto-complete it. And we hit enter. Then we are in the SSH folder. So let's check what we have in here by using ls again. And we can see that we have 3 files. We have these authorized keys. We don't really need to care about those. And then we see id_rsa and id_rsa.pub. If you remember, these are the 2 files that we have generated up here. So these are the 2 keys. And the .pub file, that is the public key. So this is the one that we need for Git. This is the one that Git needs to have saved in your profile so it can communicate with your machine. So what we can do now is we had a command to display the contents of a file. That was cat. So we do cat id_rsa.pub. And we hit enter. And this is the public key. This is what we need for Git now. So all we're going to do is just straight copy that.
And if someone thinks now that they gained something here from knowing this key, you cannot do anything with this key, only with the private key. This wouldn't be good if you show the private key, but with the public key, no problem.
Yeah, and also ensure that you upload the public key. So this exact file, not the file without the pub extension. So really watch that you get the correct key and upload this one to GitLab.
And since someone also asked in the chat, there is also a step-to-step instruction on this on the website, but we're also showing it here so you have both ways to look at it. Yeah. So we're gonna switch in the VM to our browser where we have gitlab.tographs.at open, and basically where you have to put the key, you need to go to this little icon for your profile, and there you have preferences. And if you go here, there is its own section called SSH keys. So we have already some keys here. This is going to be empty for you if you haven't worked with Git before. And then we just press add new key. And now we already copied our key from the command line, so we just need to paste it in here. Then here we have a title for the key. You can change that. You could also change the expiration date, but we're just going to leave it as is. And just press on add key. Perfect. Now we have the key saved in GitLab. And now we're able to communicate from this machine with GitLab directly. All right. So then let's get to how we can actually get our folder. So how to get our folder is we need to clone our repository. We said folders are called repositories. So either we create a repository that we want to clone, or we use an existing repository.
Yeah, we have maybe the old slides here.
Yeah,
Can you pull the slides, the new slides? So
I
because there's a
don't
change
know
to
why.
homework 1,
We technically checked before the start of the stream, but somehow.
but we will give us a short second, please, because it will get easier for you.
And please ignore the homework 1 remark here. That is
It
outdated.
says up to date.
Maybe just save the ADOC file.
Maybe that's the problem.
We just want to fix the slide because we have an old version. We work with Git, and we did not manage to get the newest version. So that's our
So as you
problem now.
As you can see, even if people have worked with Git for a long time, you can still run into issues on other machines sometimes.
Give me just a second.
We pick up a glass of water, maybe. we fix this in a few seconds.
Hopefully.
And also a break after an hour is a good choice, maybe. Maybe we have some questions in the chat in the meantime. Would the virtual machine from the TeachCenter run also on Chemo, or is it a VirtualBox specific file? That would be your question, Julia, but you're currently working.
It's VirtualBox specific.
Okay, so you can't use Chemo. You can only use the VirtualBox for the VM for x86 and the UTM for the virtual machine that you use on macOS if you have one of the M1, M2, M3, M4 chips.
Someone also asked if they need to use the pre-installed Firefox or other browsers. Okay, you can technically do whatever you want on the VM. There's just some pre-installed things, so you can just start working right away. But if you prefer a different browser or something, no one's stopping you from changing those.
So you, for instance, can install Google Chrome if you like to, or Brave browser, whatever. Yeah. One thing which is maybe important, don't update the virtual machine. So maybe you get asked, do you want to do an update of the virtual machine? Then don't do the update that you stay on the same version as we use in our tests.
Okay, so Julia fixed it, thank you. So as we said, cloning repository, you either create a repository yourself on GitLab or you use an existing repository. For the context of the assignments, the repositories will be provided to you. So once A1 is released, you're going to get an email which is saying something like, oh, access has been granted to repository something something A1. That means that you have received a repository that you can work on. So those will be given to you. And we can clone or download this repository using our SSH key that we just set up. There's one important thing to remember though, and this will happen if you work with the VM, if this is the first time that you're cloning something from GitLab, it's going to ask you if you want to trust the host that you're connecting with right now. You need to explicitly confirm that with yes. If you just press enter, it's going to default to no, and you're going to get an error, and it's not going to work. So we just need to explicitly confirm that. Right, so then let's go look at that in the VM once again. So I just need to find my repository again. All right, this is where we were. So let's say let's assume just for a second that this is just the first assignment. You received this repository from someone, and now you want to work on this. So how do you do that? Well, we've set up the SSH key, and we now want to clone the repository. I did forget to go one more thing here. We have a command for that, which is git clone, and then we need a link And this link, so what we do to get to this link is when you're on the main page of a repository, you have this blue code button. And if you click on this, you're going to see a few things, but the first option will be clone with SSH and the link right here. This is what we need for the command. So we can just press here to copy the URL. Then we go back to our terminal. We preferably go out of the SSH private folder because that wouldn't be that nice. Let's just put that.
Put it on the desktop maybe.
Yeah. Let's go to the desktop and let's clone that here. So all we need to do is git clone. And then again, let's do it this time with Control-Shift-V. And this is our command. Then we just press enter. Now, this is what I was talking about. Key is not known. Are you sure you want to continue connecting? Do not press enter here. You need to really type yes and enter. Because then Git is permanently added to the known hosts of the machine. Okay, so that should have created a folder. If we try ls again, then we can see there is this example project folder now, which is the one we just cloned. And if we can just have these two open next to each other, preferably. Kind of. Yeah, that works. We see that there's a single file in here, which is the readme.md. And if we cd into the example project, and we also do ls here, we can see that is exactly the file that we have here too. So we could work on this potentially now. Right. Then we have a little bit more to go. I need to speed up a little, huh? So now we've established a connection with Git and we've got our folder. What Git doesn't know yet is what we're called and what our email address is, because every single time we upload something, Git wants to record who actually uploaded those changes. So what we need to do for that is we need to execute some commands, and this is really important because that is a necessary requirement for the assignments, and if you don't do it at all, you can also get an error when uploading changes. We will also see that in a second. But all you really have to do is type git config, then -- global user.email. The global just means that you set it globally and not just for this one folder. User.email, and then you type your email address. Not name, but really your student email address at TU Graz, please, and also really your full name. We will have a look at that in a second, but I also want to already mention how we can upload changes to Git if we change something. We do that with another few commands. So we have git status. This just checks the status of our repository, so it shows us an overview of which files were changed, which ones will be uploaded, exactly, something like that. And we can add files for them to be uploaded if we do git add with a file name. Then we can add a commit message, which means we just add a message to the upload itself, something like added a test file or something, with git commit -m and then the message. And then we push those changes or upload those changes with git push. We will look at this now in the virtual machine.
Yeah, and don't worry if that seems like many commands to know now, you can always look them up, and sooner or later when you're working on the assignments, you would know them by heart just because you use them so often. But you can just always look them up.
Like these commands, we've probably pressed them 1,000 or even 10,000 times now in the last years where we're starting, so you will know them in 1 month, certainly by heart.
Okay, so let's just really quick try. We had the touch command before to create a file real quick. So we're just going to do touch test.txt in this example project folder, which is what we cloned from GitLab. So if we do ls now, we can see that there's not just this readme file anymore, but also this test.txt file. So if we do now one of the commands for Git to check the status of the repository, git status, it will tell us, there's untracked files, use git add and the file to include what will be committed. So it's telling us, oh, there's a file that we don't have online yet, or that received some changes or something. and that it's telling us, okay, these can be uploaded if you want. So we want to do that now, so we're just going to do git add test. And here we can also do the autocomplete with the tab button, git add test.txt, enter, and we do git status again. And it's telling us, oh, there's a new file now that we have added, test.txt. Now let's set a message for the upload of this file with git commit -m, and let's just say add a test file. And now we do enter. And now it's telling us author identity unknown. So this is why you need to do the git config commands. And it's also telling you right here that you need to do these exact ones.
Maybe to mention this, every time we do this course, there is someone who asks what he needs to do if he sees this message. But if you read through the message, it really tells you what the error is and what you need to do. So maybe if you watch the stream now, you are aware the answer is stated in the error message. Perform the actions that are written for the answer, and don't ask on Discord what you need to do if you see this error message, because there's really the solution to the problem written here.
Right, and here you want to put your student email. Because we're almost out of time, I'm just going to leave the example thing now just so we have something. So you've seen it once, that how it works. Is that, and we enter. And if that's also a neat little trick, if you're in the terminal and you use the arrow keys up and down, you can switch between commands that you have just entered. That's also really nice if you want to be quick about things. So we can just type in 1, 2, 3 times the arrow key up, and then we can just do the git commit again. Now it's working. It's telling us there was one file that was changed. 0 insertions and deletions because the file was empty. And if we do git status one more time, we can see, we are ahead by 1 commit. That is the one we did just now. Use git push to publish them. So we are going to do just that, git push. And that should have uploaded. And as you can see, it already updated here, that we see, well,
It uploaded the commit message, but
right,
it didn't show the test file yet.
Right,
yeah.
so we have the test.txt file. It also telling us that the last commit where this was changed was add a test file. And here it's telling us that we added a test file. We can also look directly into the commit, and then we see that we had one changed file. Yeah, it's not showing us anything because the file was empty, but technically you would see things here.
Yeah, and here you also see the reason why you really need to enter your name, because right now there's just your name here, but we need to know that really you did this. So yeah, just please set your name with the git config, the correct one.
Right. Technically we're out of time now, right?
Oh, we have 5 more minutes.
Okay.
We did the break and we started 2 minutes later, so we have 5 more minutes.
Okay,
now.
okay. So you already saw the Hello World program last week in the lecture, as well as in the weekly exercises of the first week. We are going to write this on our virtual machine now and push it to Git, and also run the entire program. So for that, we can, which is also really nice, we already saw that before, that you can execute a program within a directory. So we can actually just open Visual Studio Code right from the terminal. If we just do code, then we use the dot for the current directory, and we just press enter, and we will get a Visual Studio Code window right in this example project folder. Yes, we need to trust the authors because, yeah, it's just asking us that. And then we can also just right in here already create a file.
Maybe can you zoom in a bit, that it's a bit larger?
Of course.
Yeah, perfect.
So we can create a new file through this button here. And we're going to call this helloworld.c, which is what our program will be called. We do not need this. And then we can just go over here again. In the interest of time, I'm just going to copy it now. And we just did that. So let's pretend we already wrote the program. If you remember, all the program does is really print to the terminal the text that we have written in here with the printf function. If you are in this code editor, you can use Control S to save your changes. Do not forget to do that before you try to do anything else with your program. It's always good to save in the meantime, never hurts. Right, so now we have our Hello World program here. And what do we also want to see what it does now. So how we can do that is by compiling the program and then running it. So basically, if you compile the program, that just means that you turn the code that you wrote in C into an executable file with the help of a compiler. You will learn more about the compiler, I think, next week, if I'm right. Yeah.
In the lecture, yeah.
Yeah. So all we need to do now is just look how we can compile a program for starters. We have this command here, which starts with clang or clang. That is just the name of the compiler that we're using. You can use a different compiler, but we're going with this one now. Then we have -o hello world. The -o is just specifying that anything that comes right after it will be the name of the executable file. So we want
Sorry, the executable file is just what you under Windows would be an .exe. So it's just something you can run. Yeah.
And last but not least, we have helloworld.c, which is what we called our program and is the file that should be compiled, which we want to run. And we can then run the program by typing // and the name of the executable. Yeah.
Okay, then let's see this in practice for the Hello World. We
Yep.
need the terminal first.
So we are in here now. We can check again. Okay, we have our helloworld.c. So we said we're doing clang -o hello world. That's what the executable will be called. And then we're doing helloworld.c. We can also use tab here again. Then we can do ls again, and we will see there is an additional file. It's also green because it's an executable. And then we can do /the hello world and enter, and we have our hello world text. This is how we can run the program. One more thing to mention would be if you do something like clang without the -o and you just do hello world.c, something else happens because you're not specifying the name for the executable. What happens is that you get this a.out file. This is just the default name of the executable that is chosen. So if you ever forget, like when you work on the assignment, if you ever forget to if you manually compile and you forget this, and then you wonder, oh, what is this a.out file? I don't remember creating that. That's just because you probably forgot that at some point. And what's also interesting is if we try to change positions of these two files. So what if you just say helloworld.c and then hello world? Does that work? We will look at that too. If we have helloworld.c and then just hello world, then it's going to fail. Why is it going to fail? Because we did already have an executable in here called hello world, and it now tried to compile the executable, which doesn't work because it's already executable and there's no code, that the shape is wrong. So that's why it's telling us that the linker command failed. The error looks a bit different if we didn't have this already here, but basically the order needs to be like this.
Yeah. And also be careful about switching this up, because if you put the C file as the output file, Clang will delete it. You see it's gone now. So don't do that.
Oh, right. I should have shown that, right?
No, it even got deleted the Hello World. But you see it in the background in Visual Studio Code.
Yeah.
So don't do that. Okay, I think this concludes now everything. So just to sum up what we have seen today. So we started with the wiki exercises and the virtual machine. And then we had a look on these Linux commands. And then at the end, we discussed about Git and GitLab and also finally implemented the Hello World on our machine now. So the goal for you would be now to set up everything within the next approximately week, because in 1 week's time we will release the first assignment, and it's probably better that you're prepared before the assignment is released.
Yeah, because then when the assignment releases, you can already git clone it and start working instead of, I don't know, just debugging some virtual machine problems that you could have already solved a week ago.
Okay, this concludes then our first practicals. In a few minutes the lecture will start, maybe with a slight delay of 5 minutes because we took now a bit longer. So stay here for the lecture, watch the lecture, and then but you will see the two girls in next week, and I will be there in 2 weeks again. Bye.
Bye.
Bye.